Note sheet for you. You're going to have to do some old school notes here, but it won't take very long. Today we're going to learn about one quick theorem called the hospital.
Wow.
Okay.
There's no S. It's hospital.
It's French.
Right. It's French for the hospital. That's the guy's last name. His last name was the hospital. Just like Eunice, it's the park. Right. Yeah. I'd have to think if anybody else has names like Susie Esquale.
Yeah.
Susie School. Anyways, let's get back to this. So we're going to go back to limits. I know how much you love limits, so I figured we'd bring them back. Okay. Taking limits, we did that quite a bit. That was our first thing. I know you're flashing back right now. But we had a process in place. Okay. What's the first thing you do with any limit? Maria, say it loud and proud.
Make sure it's continuous.
Nope. Anybody else? What's the first thing you do solving any limit problem? Plug and chug, correct. And then we ran into some problems. Most of them were easy. If you plug and chug and you get a number, you're done. However, when we got into the problems where they became a little nastier, if the plugging and chugging didn't work, you then did some algebraic manipulation. And then hopefully that worked. And at some point, some of those problems you just had to give up on. L'Hopital's will allow us to take the limit of rational functions. So we'll have this rational function of a over b. Probably a more eloquent way to do that would be to say we've got a rational function of f of x over g of x. Okay, rational function, it's in the form of a ratio. The other limit rules still apply here. But what L'Hopital's allows you to do is solve those problems where after you plugged and chugged and it didn't work, and then you algebraically manipulated and it didn't work, and you plugged and chugged again, it didn't work, and you just did DNE, L'Hopital's will allow you to solve those limits in special scenarios. Okay? Those scenarios are called indeterminate forms. Indeterminate forms. We're going to look at two easy ones today. They are 0 over 0 and infinity over infinity. There are others, and the other ones are the ones that are going to take the most time. This is pretty straightforward. So L'Hopital says this. If you take a limit by plugging and chugging, and you get one of those indeterminate forms, up until today you would say DNE. However, L'Hopital discovered something, and that is that if this happens, then you can take the derivative of the top and the bottom and do it again. Okay, that doesn't make much sense, but I'll show you what I mean. If the limit as x approaches c of f of x over g of x equals 0 over 0 or infinity over infinity, then you can do the limit. Whoa, what happened there? The limit as x approaches c of f prime of x over g prime of x. Okay. Now notice, that's not a quotient rule. It's literally the derivative of the numerator over the derivative of the denominator. Hold, please. I see you, Danny. I got you. Thanks. This is the wrong thing. I forgot where I put my notes. Here we go. Okay, so let's look at an example here. I will warn you, what some of you are going to do is you're going to start applying L'Hopital's rule to every limit that you do from this point on. You have to check to see if it's one of these indeterminate forms first. If it's not 0 over 0 or infinity over infinity, L'Hopital's doesn't work. Okay? So we'll do something pretty straightforward here. Let's do limit as x approaches 0 of 3 times the cosine of x plus 5x minus 3 all over 2x. Okay. You gotta check. So plug and chug. And when you plug and chug, what do you get?
Zero.
Is that it?
0 over 0.
0 over 0. Cosine of 0 is 1. 3 minus 3 is 0. 5 times 0 is 0 over 0. So we have 0 over 0. Check. Now I've entered that realm of indeterminate forms, and we can apply L'Hopital's. If it's not 0 over 0 or infinity over infinity, then L'Hopital's doesn't apply. Now there's other scenarios. We'll get to those on Friday. For today, I'm just going to look at these two. Okay, so then L'Hopital says, well, if this doesn't work and gives us an indeterminate form, then I'm going to take a derivative. Go ahead, take the derivative of the top and the bottom. I'll do the bottom for you. There you go. You're welcome.
Can I do plug and chug?
Correct. Max, what's the derivative of the numerator?
It's 3. Wait. Using quotient rule or
No quotient rule.
so 3 negative sine x plus 5.
Well done. Okay. Again, not quotient rule. Okay. It's easier than that. Plug and chug again. What's the sign of 0? 0. So we get an answer of 5/2. Done. Now you're saying to yourself, self, this seems too easy. Where's the trick? There is no trick. The only thing you have to remember is you've got to check to see if it's an indeterminate form. Notice, if I plug in 0 and I get a number, I'm done. That's the limits we did months ago. This is L'Hopital's gets us into this weird realm of infinity over infinity or 0 over 0. Okay? Questions?
Why-
Beautiful. Go ahead. Who's talking?
Me, sorry.
Yes.
I'm just confused as to why we can do it. Like, that's not how quotient rule works, and it's not how. like,
It's
I
not
don't- I don't
quotient.
get
Can we see a proof? of this?
So you,
it. No, I don't wanna see the proof.
I don't think I could do the
layman's
proof of it off the top of my head.
Can you see the graph of this?
You could graph that if you
We're just gonna
like.
have like blind faith.
Yeah,
it
you
works.
gotta trust the old dead French guy, okay?
The bully?
I'm sure that our textbook has a proof of L'Hopital's. I don't know why you wanna look at it.
No, I don't know, I don't, it doesn't feel like.
You're questioning authority.
More just like I don't get why you can, I don't get it, but it's fine.
Right.
I'll just do it.
I get it 100%. I get that you don't get it, or don't want to accept it. It seems too simple.
Uh-huh,
Right,
and it feels illegal, it feels like I'm doing bad math.
right, I get it. You're not, because L'Hopital said you're not. And I trust him, he has an honest face.
What's his face?
Well, he's dead, but I mean, he's good.
Like, he had that like a little portrait or something.
Yeah, you could find a picture of L'Hopital, and
What was
he's,
his first name?
Renee? No. Yeah, the. Is that what you said?
I said look.
Oh. Yeah, I don't know his first name. Just type in L apostrophe Hopital. Hopital.
Mathematician.
Yeah, then switch to images.
No, I'm just,
See, he's an honest looking guy.
No, he's not.
Has he got a funky wig on?
Yes.
Yeah, they all wore the funky wigs.
Oh my god. There are two very different portraits of him.
Okay. Last thing before we get done with this is that we talked about this takes care of 0 over 0, infinity over infinity. We're going to look at some other indeterminate forms. Some of that, or one of them, is 0 times infinity. That's coming up. Another one would be 0 to infinity or infinity to 0. These we're not going to spend a ton of time on, but we will talk a little bit about them. Okay. For now, we're just going to start with the two most common. Every question I've ever seen on L'Hopital's on the AP test has revolved around these two. There, like I said, there are some more obscure ones, but for now, we're just going to focus on this. Okay. Two things to remember with L'Hopital's. Number one, you must check to make sure that it's an indeterminate form. And number two, it's not quotient rule. It's derivative of the numerator over derivative of the denominator. Okay? Make sense? Beautiful. Again, you won't be able to finish. In fact, you won't be able to complete a majority of the homework, but at least it'll give you an opportunity to delve a